Every week, I see another video telling students to use ChatGPT for studying, and the advice is always the same. Ask it to explain concepts. Use it to summarize your notes. Let it write your essays. That's not helpful. That's obvious. And honestly, for physics, math, and chemistry, ChatGPT alone isn't even that good. Most students think AI study tools means one thing: chatbots. You type a question, you get a text answer, maybe it's right, maybe it's wrong, and you move on. Here's what nobody talks about. There are specialized tools built specifically for STEM subjects that do things chatbots literally cannot do. Tools that solve equations step by step and show you the exact method. Tools that turn abstract formulas into visual interactive graphs you can manipulate. Tools that let you run physics and chemistry experiments without a lab. Tools that turn your lecture recordings into study systems, and most students have never heard of them. I've spent years testing every AI and computational tool I could find for science and math courses. These 8 tools are the ones that actually made a difference. Not gimmicks, not hype, real academic leverage. I'm going to show you each tool, explain exactly what it does that others can't, and give you specific use cases for physics, math, and chemistry. By the end, you'll have a complete system for studying smarter, not just harder. Let's start with the most powerful calculator most students don't know exists. Wolfram Alpha is not a chatbot. It's a computational knowledge engine. The difference is crucial. When you ask ChatGPT to solve an integral, it predicts what the answer probably looks like based on patterns. When you ask Wolfram Alpha, it actually computes the answer using mathematical algorithms. One guesses, one calculates. Let me show you what this means in practice. For mathematics, type any equation from basic algebra to differential equations, and Wolfram Alpha doesn't just give you the answer. It shows you every single step. Solve x3, 6(2 + 11x, 6 × 0. You get the roots, the factorization method, a graph of the function, and the complete solution process. For physics, you can input physics problems directly. Projectile motion, initial velocity, 20 meters per second angle, 45 degrees. It calculates range, maximum height, time of flight, and gives you the trajectory graph. For chemistry, balance the equation, Fe plus O2, Fe2O3. Instant balanced equation with coefficients and molar ratios. You can even input molecular formulas and get 3D structures, properties, and reaction predictions. Here's why this matters for your grades. When you're stuck on homework, you don't just need the answer. You need to understand the method so you can replicate it on the exam. Wolfram Alpha shows you the method. It's like having a tutor who solves the problem on a whiteboard, step by step, available 24/7. But computation is only half of understanding. The other half is visualization, and that's where the next tool becomes irreplaceable. GeoGebra is actually 3 tools in one, and most students only know about one of them if they know about it at all. Let me break down all 3. First, GeoGebra Graphing. This is your advanced graphing calculator. But unlike a physical calculator, you can interact with the graphs in real time. Type a function, see the graph instantly. Add a slider for a variable. Watch how the graph transforms as you change values. This is transformational for understanding calculus. Want to see what happens to f uterus x2 as a changes? Create a slider, move it. Watch the parabola stretch and compress in real time. Suddenly, abstract coefficients become visual intuition. Second, GeoGebra Classic. This is the full suite. Graphing plus geometry plus 3D visualization plus spreadsheets plus QS. For physics, you can model vector addition visually. For chemistry, you can visualize molecular geometry in 3D space. For math, you can construct geometric proofs step by step and see the relationships. Third, the main GeoGebra platform. This gives you access to millions of interactive resources created by teachers and students worldwide. Search electromagnetic induction and find interactive simulations. Search integration by parts and find step-by-step visual explanations. Search orbital hybridization and find 3D models you can rotate and explore. Here's the insight most students miss. STEM subjects are not meant to be learned through text alone. Physics is about motion and forces you can see. Chemistry is about structures and reactions you can visualize. Mathematics is about relationships and patterns that become obvious in graphs. When you only read formulas, you're learning with one hand tied behind your back. GeoGebra unties that hand. Now, visualizing math is powerful, but what about subjects that need actual experiments? You can't run a chemistry lab or physics experiment on a graphing tool, or can you? PhET is a project from the University of Colorado that has created free interactive simulations for physics and chemistry. These aren't animations, they're actual simulations. You change variables, the physics engine calculates the results. You see what happens. For physics, there's a simulation for projectile motion where you can set the angle, velocity, air resistance, and mass, then launch and see the actual trajectory. There's a circuit builder where you drag resistors, capacitors, batteries, and wires, connect them, and see current flow and voltage readings in real time. There's a wave interference simulation where you control frequency, amplitude, and phase, and watch the interference patterns form. For chemistry, there's a molecular polarity simulation where you build molecules and see electron density distributions. There's an acid-base solution simulation where you mix acids and bases and watch pH change with indicators. There's a states of matter simulation where you control temperature and pressure and watch molecules transition between solid, liquid, and gas. Here's why this matters. Lab time is limited, equipment is expensive. Mistakes in real labs can be dangerous. But understanding comes from experimentation. PhET lets you experiment infinitely. Test extreme values, make mistakes, see what breaks, develop intuition. When you walk into the real lab or the exam, you've already felt how the physics and chemistry work. You're not just recalling formulas, you're recalling experiences. All right, so now you can compute, visualize, and simulate. But what about research? When you need to actually understand a concept deeply, where do you go? Perplexity is not ChatGPT. It's an AI-powered research engine that searches the web, synthesizes information, and cites every source. For academic work, this distinction is critical. When you ask ChatGPT to explain quantum entanglement, it gives you text generated from its training data. No sources, no way to verify, no path to go deeper. When you ask Perplexity the same question, it searches current academic and educational sources in real time, synthesizes an explanation, provides numbered citations for every claim, links to the original sources so you can read more. For physics, math, and chemistry, this means you can ask complex questions and get explanations with citations to textbooks, papers, and educational resources. You can verify that the explanation is actually correct by checking the sources. You can follow the citations to build deeper understanding. Here's the practical value. When you're writing a lab report or a research assignment, you need sources. Perplexity gives you the explanation and the sources simultaneously. When you're trying to understand a concept and don't trust AI accuracy, you can verify immediately. When you're exploring a topic for a presentation, you get a roadmap of credible resources to explore. It's the difference between trusting blindly and trusting with verification built in. Now we have computation, visualization, simulation, and research covered. But there's one more gap. How do you turn all of this into actual learning that sticks? The final two tools close that gap. These two tools take your own materials, lectures, notes, textbooks, and transform them into personalized study systems. Let me explain each one. NotebookLM by Google. You upload your sources, PDFs, lecture notes, research papers, even YouTube video links. NotebookLM reads everything and becomes an expert on that specific content. You can ask it questions, and it answers only from your materials with citations. You can generate study guides, summaries, and even audio discussions about your content. For a physics exam, upload your lecture slides, textbook chapters, and problem sets. Ask, what are the key equations I need to memorize for mechanics? It gives you the answer based on what your professor actually taught, not generic information. Ask, generate practice questions based on these materials. It creates questions specific to your course content. MindGrasp AI. This tool is built specifically for students. Upload a lecture recording and it generates detailed notes with timestamps, flashcards for key concepts, practice quizzes, summaries at different levels of detail. For a 2-hour chemistry lecture, upload the video. Get a complete set of notes in minutes. Get flashcards automatically generated from the key terms. Get a quiz to test your understanding. Here's the insight. The bottleneck in studying is not access to information. It's converting information into usable study materials. Taking notes is slow. Making flashcards is tedious. Creating practice tests is time-consuming. These tools automate the conversion. Your time goes to actual learning, not administrative prep work. And because they work from your specific materials, the output is tailored to your specific exams. Now let me show you how all 8 tools work together. You're taking a physics course on electromagnetism. Step 1. Use Perplexity to research concepts you don't understand. Get explanations with sources. Step 2. Use Fichet simulations to experiment with electromagnetic phenomena and build intuition. Step 3. Use GeoGebra to visualize the vector fields and mathematical relationships. Step 4. Use Wolfram Alpha to solve practice problems step by step and learn the methods. Step 5. Upload your lectures to MindGrasp to generate notes and flashcards. Step 6. Put everything into Notebook LM to create a personalized study assistant for exam prep. That's a complete system. Research, experiment, visualize, compute, organize, review. Each tool does what it's best at. You do the learning. Let's bring this together. Wolfram Alpha computes and shows you the method step by step for math, physics, and chemistry problems. GeoGebra turns abstract formulas into visual, interactive understanding you can manipulate and explore. PhET gives you a virtual laboratory where you can experiment infinitely without risk or cost. Perplexity provides research with built-in verification through cited sources. Notebook LM and MindGrasp transform your own materials into personalized study systems. 8 tools, 1 integrated system. At the start of this video, I said most AI study advice is superficial. Just ask ChatGPT. Now you see why that's not enough. These specialized tools do things chatbots can't do. They compute accurately. They visualize dynamically. They simulate realistically. They cite sources. They personalize to your materials. That's real academic leverage. The students who will excel aren't the ones who avoid AI, and they're not the ones who use AI to avoid learning. They're the ones who use the right tools to learn faster and deeper. Now you have those tools. If this changed how you'll approach studying, like this video. Subscribe if you want more systems that actually work, not just hype. And I'll see you in the next one.